Hello everyone, welcome to my channel. Let's sort the list using the insertion sort. So what does it insertion sort say? We know some partially sorted list we got, and then we will keep growing it by adding new elements. So let's say we have this list 1, 5, 3 and 2, and if you see till that point this list is already partially sorted. Now we are going to find the right place of the node of value 3. So we will start from here, two pointers, like one pointer is next pointer, keep here, and the previous of the pointer from the next. So we will check if the next dot value is greater than, like we have to find where this pointer will go after the in the sorted list. So we will compare, 1 is not, 5 is greater. So when next comes here and previous will be over the takes the place of the previous next. So this will be here. Now we can see that this next is greater than the current we are processing, and this is the current. So now we will change the pointers and move this 3 into the correct place. So how we will? So we will first update this previous dot next will be point to this node, and the current dot next will point to the next node, so that this node will inserted in between 1 and 5, and then we will update the current to the current next, and but we have to keep track before changing the current next point in some temporary variable. So we can say that current dot next. So this is the way we will keep follow. So after first iteration this will become 1, 3, 5 and then 2, and our current will be over here. So same step we will follow for this as well. So one previous next will be here, then previous will be on the null, pointing null, and then we will compare, then previous will move to the next pointer and previous will come here. Then we found that this next value is greater than the current node we need to place at. So we will change again the pointers, and there is a last node which will be null over here. So the current next will be here, and this pointer will point to next to this, and the next of previous will point to this current pointer. So this will also we place in between node 1 and 3. So this is the step we will follow. So let's implement the code. So first we will take the dummy node that initialize from the some dummy node, which is let's say -1 value, and in the end we just need to return dummy dot next. So this will be the dummy. Now we will initialize another pointer, current node, from the head of the list. Now we will run this list until we process all the node current not equals to null, and then we also create the few node pointers. First let's say temp, which will hold the current dot next, so that we will link later current to current dot next, and another list node previous and next from the. So this we will start previous node from the dummy, and another list node next, let it nxt, from the dummy dot next. So we will run another inner loop while the next not equals to null, or we will also check once the next dot val cross the current value, which means we find the place where we have to insert the current value, we will break that loop. Otherwise, if it is not the case, we will update previous pointer by the current next and the next pointer by the next dot next. So that is how, once we found the place, we need to link, like this part, like we need to change the pointer previous to this, and so we will point the current dot next will become next pointer, and the next pointer previous dot next will point to the current, and we will update current with the temporary, here we saved in the temporary pointer current dot next. So this is the implementation. So let's compile the code, and it is working. So let's submit the code, and it is accepted. So the time complexity of this solution, as you can see, we are running this scanning the whole list once over here, and then nestedly we are also scanning again this list one more time. So the basically if you want to calculate exact time complexity, let's say we have some node, let's say 4 node. So for first node this will scan 0, then 1 for this node, then 2, then 3. So this will become a basically AP, arithmetic progression, and once the sum will become n plus n by 2, and in terms of O, big of O, we can say that this is O of n square time complexity. And the space complexity, as you can see, we are just using few reference pointers, so which is constant. So if you like this solution, hit the like button, and I have another video like sort a list with using the merge sort. You can try the sort using the merge sort as well. That is a n log n solution. So try it out. Thanks for watching.